Hello, my dear students friend. So today I am going to discuss something from the branch of mathematics, algebra. Okay. So students, see, often I find that you find difficulty in algebra. So to clear that one, let me start from the basic things. So in my first video on algebra, I already discussed about algebraic terms, okay, like terms, unlike terms, etc. Regarding algebraic terms, variable, constant, coefficient, everything I discuss in details. Now today I am going to discuss about algebraic expression. So my today's topic is algebraic expression. So what is an algebraic expression? That today we are going to discuss. See, algebraic expression means, let us first consider some algebraic terms. Say twice x is an algebraic term, minus 1 by 3y square is an algebraic term, okay. Then say root over 2 xz is an algebraic term, okay. Then say minus 3z cube is an algebraic term. These are some algebraic terms, okay. Now suppose I take one algebraic term or more than one algebraic term. Suppose I take only one algebraic term, say twice x. Suppose I take two algebraic terms, say twice x and minus 1 by 3 y square. And suppose when I take more than one algebraic term, suppose I connect them by plus sign. Plus means ultimately the sign will be here, plus and minus, ultimately it will be minus sign. Suppose I take three algebraic terms, okay, I take three algebraic terms and I connect them by plus sign, okay, like that. So now when it is, that means what you have seen here, it is one algebraic term, it is sum of two algebraic terms, sum of three algebraic terms, okay, or I can take all the four algebraic terms, so you will get like that. So sum of four algebraic terms these are sum of four algebraic terms. So when it is one algebraic term or more than one algebraic term connected by plus sign, or sum of more than one algebraic terms, it is called as an algebraic expression. So these are all examples of algebraic expression. So your algebraic expression may contain only one term, okay. So your algebraic expression is such that it may contain only one term, it may have two terms, sum of two terms, it may be sum of three terms, it may be sum of four terms, it may be sum of any number of terms. So this is called as an algebraic expression, okay, clear regarding the algebraic expression. Now according to the number of term, we can classify them, classify the algebraic expression. How we can classify the algebraic expression? See here I have only one term. So when I have only one term, we call it as monomial. We call it as monomial. Monomial means algebraic expression having one term only. Then if there are two terms, then we call it as binomial, okay. If there are two terms, then we call it as binomial, okay. If there are three terms like this, we call it as trinomial. We call it as trinomial if there are three terms. If there are four terms like this, we call it as quadrinomial, like that one, okay. So according to number of terms, we can classify the algebraic terms as monomial, one term, binomial, two terms, trinomial, three terms, or quadrinomial, four terms, like that one, okay. Now your algebraic expression, here you see whatever the algebraic terms I have taken here, some of them has only one variable, some of them have more than one variables, power of the variable 1, 2, 3, etc. okay. So you already know that an algebraic expression may contain, an algebraic term may contain any number of variable, means an algebraic term may be product of 2, 3, 4, any number of variables. The power of the variables can be any real number, okay. Then the coefficient of the variables can be any real number, okay, you know that one. That means if suppose I write like this one, say 1 by x minus say root over 2 root over y plus z to the power 1 by 3. This is also an algebraic expression. But in this algebraic expression, if I see the power of the variables, they are not whole number, okay, or not integer. They are not whole number, not positive integer, not whole number. It is say -1 in negative integer. Here root over y means y to the power 1 by 2. It is a fraction. Z to the power 1 by 3. It is a fraction. It can be like this also. Now, next thing we are going to discuss about an algebraic expression. Okay. Next, what we are going to discuss? We are going to discuss about an algebraic expression. I am going to discuss about an algebraic expression. Okay. This algebraic expression is such that means it will have some condition. Okay. What are the conditions? First condition is, okay, only one variable is used in its term. Only one variable. Okay, the algebraic expression may be monomial. Then if there is only one term, then only one variable is used in that term. It may be binomial, two terms are there. But unlike this example, here I have used two different variables. So there will be only one variable. Okay, clear? Then number two condition is index or power. Let me write it as power of that variable. Power of the variable in all the terms. In all the terms are whole numbers. I think all of you know whole numbers. Whole number means 0, 1, 2, 3, etc. That means it cannot be an algebraic expression like this one, where power of the variable is other than whole number. So this type of algebraic expression. Okay. So an algebraic expression where there is only one variable is used. Okay, that means it cannot be like this one, second one, third one, or fourth one, where more than one variables are used. Okay, power of the variable in all the terms are whole number. Here it cannot be like this, where the power of the variable is other than whole number. That means if I try to give some examples of this type, then it can be like this one, your first example, twice x, okay, where variable is x only. It can be of this type, say y minus 7 y square plus 5. It can be of this type, variable is only one, y. If you see the power of y in different terms, there are three terms here. Okay, so y to the power 1, y to the power 2. Here y is not there, means actually y to the power 0. So powers are 0, 2, 1. These are all whole numbers. Okay, let me take another example, say z cube plus 7 z square minus 6. Okay, it is an algebraic expression where these two conditions are satisfied. I have used only one variable in all these three terms, and if you see that power of that variable z in all the terms, they are whole number. Okay, so this type of algebraic expression. Okay, so what is the name of this type of algebraic expression? The name of this type of algebraic expression is polynomial in one variable. Polynomial in one variable. So what is polynomial in one variable? The polynomial in one variable is an algebraic expression such that this one. Okay, so it is a polynomial in one variable. So it is an algebraic expression, but it has two specific conditions. Okay, so now here you see so I think it is clear to you that which algebraic expression is polynomial in one variable. I think it is clear to you. Okay, so now in standard form, whenever you write a polynomial in one variable, then you have to always start from the highest power of the variable. Then that power of the variable decreases by 1 in each term up to the last whole number 0. We should write it like that. Okay, we should write always like this one. That means we have to, like here, we have to start with the highest power of the variable. So here, what is the highest power of the variable? 1. then you have to write up to 0. That means this twice x, if I have to write in standard form, then answer will be twice x plus x to the power 0. But x to the power 0 is not here. Okay, so you multiply them by 0. Okay, like here this one, say y square, y minus 7y square plus 5. If I have to write in standard form, then here what is the highest power of the variable y? It is 2. So I have to start from the term containing y to the power 2. So what is the term containing y to the power 2? 7y square. This is the term containing y to the power 2. Okay, then I have to write the term containing y to the power 1, because the power of the variable decreases by 1 in each term. So next it will be y. Then I have to write the term containing y to the power 0. So the constant term actually contains y to the power 0. So this is the standard form of this polynomial in one variable. Similarly, if I have to write this polynomial in standard form, then you see here z cube, okay, then 7z square up to this, okay. Then next it should be a term containing z to the power 1, that means containing z. But in our given polynomial, there is no term containing z, so it will be now 0 into z to the power 1 plus 6, sorry, not plus 6, minus 6 into z to the power 0. It is the standard form of a polynomial in one variable. That means in standard form of a polynomial, what we have to do? Suppose our variable is x. Suppose our variable is x, and suppose highest power of x is n. Okay, in a polynomial, suppose we use the variable x and highest power of x is n. So we have to start from the term containing x to the power n. Okay, then next term will be what? The power of x decreases by 1 in descending order, decreases by 1. So next term will be x to the power n minus 1. Next term will be x to the power n minus 2. And the last term will be x to the power 0. Up to 0 you have to write it. That means if our n is 1, then 1 and 0. If our n is 2, then 2, 1 and 0. If our n is 100, then 100, 99, 98, 97, in this way up to x to the power 0. Up to that you have to write it. Next thing is that, like here if you see in these examples, every term has some numerical coefficient like 1, 7, 0. Okay, every term has some numerical coefficient, and those numerical coefficient can be any real number. So that means we have to write symbols of some real number which are the numerical coefficient. So suppose symbols of real number I have taken like this. Symbols of real numbers which are the coefficients of the terms, I have written in this way. Okay, I have written like that. Now you may have a question that 0, 1, 2, if they have some values or not. Okay, this 0, 1, 2, are they significant? Are they the value of something? No, nothing. Just these are symbols. Okay, these are symbols. A0, this 0 has no meaning. This 0 has no meaning. Just it is a symbol of a real number. Just there are different types of real numbers. This A0, A1, these are different. So I put 0, 1, 2, etc. to distinguish them, to separate them. Okay, so here these are nothing but are numerical coefficient, and as you know that in an algebraic expression, numerical coefficient can be any real number. So these are any real number. Okay, so this is the general standard form of a polynomial where variable is x, highest power of the variable is n. So symbolically you can write it p, the letter p you can use for polynomial. Okay, it can be used p, q, or whatever. In bracket the variable is used in the polynomial, you will write it. That means you write x. So px is the standard form of a polynomial of degree n. Okay, highest power of the variable is n here. Okay, clear now? Now whatever the highest power is here, like here in this example it is n, in this example it is 3, in this example it is 1, in this example it is 2. That is called as degree of the polynomial. Degree of the polynomial. So what is degree of the polynomial? Degree of the polynomial is what? Highest power of the variable. Highest power of the variable. It is the degree of the polynomial. So in this polynomial, what is the highest power of the variable? It is n. So degree is n. In this polynomial, highest power of the variable is 3. So degree is 3. Here the highest power of the variable is 2. So degree is 2. Here highest power of the variable is 1. So degree is 1. Okay. And one thing remember, whatever the coefficient is there in the highest power of the variable, that must be a non-zero number. Otherwise, what will happen, if suppose it is 0, then you have to start from this term. Actually, you will see this term only. And here highest power of x is n minus 1. So then you cannot write that highest power of x is n. So to write highest power of x is n, or to write that degree of this polynomial is n, so one thing must be there, that the term containing x to the power n must be there in the polynomial, and the term containing x to the power n will be in the polynomial only when its coefficient is non-zero, other than 0. If it is 0, then 0 into anything will be 0, so the term will vanish. Okay, so that's why the coefficient of the highest power of the polynomial is always non-zero. Okay, clear? So now, based on this discussion, we come to know what is algebraic expression and which algebraic expression is called as a variable. Okay, which algebraic expression is called as a polynomial in one variable. What is algebraic expression and what is the polynomial in one variable that we discuss? We discuss the standard form of polynomial in one variable and degree of the polynomial in one variable. In my next video, we'll discuss something in details about polynomial in one variable. Okay, so keep watching the videos, like the channel, subscribe the channel, share it among your friends. Okay, and let us together make the mathematics simple, easy, interesting for everyone. Thank you once again, all of you. This much for today. Bye bye. Take care.